All right, here we are. Continuing functional groups. If you are confused, you got to have table R available. Excuse me. And just take it slow. I know there's a lot, but table R is always there, and practice, practice, practice. We have a lot of worksheets that you can work on. There are always online resources, Regents chemistry, organic chemistry, because if you search just organic chemistry, you're going to get college level, and that is a lot harder. So make sure you always include Regents chemistry or New York State when you search. And I can provide some more that are more directed. So anyways, we're just continuing with some other functional groups we didn't get to. So first one here we're going to talk about is an ether. So find ethers on table R. You'll notice it's a single bonded O in the middle of two carbon chains. And so the naming for this is a little bit different. So before we would just kind of chop off the ending and call it, propanol if it was an alcohol, propanal if it was an aldehyde, propanone if it was a ketone. But this is completely different. So notice that my picture looks a little different than table R because, do you remember those? The lone pairs repulsing outward? Technically, it shouldn't be straight across, but you know what? That's the regions for you. So how do we name this? You know what? Let's take a look at table R. Under ether, it says methyl ethyl ether. So if you look, one side of the O has a methyl group. The other side has an ethyl group. So it's small chain, long chain, ether. Shorter, longer, ether. What if the chains are the same size? Di. So it's about that time. What if I were to draw this? All right, get ready. Well, you know what? That actually comes up. I'm going to make you wait for it. My corny joke. All right, let's get to it. CH3O, CH3. You are welcome to write the H's in here, but remember, as organic chemists, we understand that there are H's there, so to save time, you don't have to. CH3O, CH3. So this is an ether. We know that because we have a single bonded O in between two carbon chains. Now, what is the size of the carbon chains? This one is a methyl. This is also a methyl. So do we say 2-methyl? No, we say dimethyl. Ether. And we don't need to give a location because it's always in the center. So actually, that's something we should go back. No location needed for these. So here's my corny joke. Are you ready? Let me choose. They don't have pink. I guess magenta is the closest. Oh my gosh. This is bad. What do you see? What is that? This is the ether bunny. You like that?
Very nice.
Mr. Mitiga enjoyed my corny joke. Can't you see it? Ears, ether. Oh well. I would hear groans if you were here. All right, let's do this next one. CH3. O. CH2. CH3. Short chain, long chain, ether. Short chain, right here. Whoops. Methyl. Long chain, 1, 2. Ethyl. Oh, this is the one from the reference table. Ether. Now, what if I added another one on here? What would that be? Meth, eth, prop. Propyl. So, that's pretty easy. Okay, organic acids. You should be looking for the COOH ending. So, you might have also heard the phrase carboxylic acid. That's the same thing. I don't know why the Regents just decided to change its name. So we're going to go with it. So organic acids, COOH. So take a look at table R. It's a C double bonded O to an OH. C double bonded O to an OH. How do we name an organic acid? Well, if you look at the example, it's just chain oic acid, methanoic acid, ethanoic acid, propanoic acid, butanoic acid. And since it's always going to be at the end, no location needed. All right? So we don't need to say 2 or 1. It would always be 1, but no location. CH3COOH. CH3COOH. Tricked ya. That would never occur. Okay, so let's go back. So if you tried to do that, that should look weird. That should not be how it works. So if carbon needs 3 bonds, 3 additional bonds, it already has this one. If it needs 3 additional bonds, but there's only 3 like this, COOH, C double bonded O to OH. So now this is ethanoic acid. Okay. COOH. Well, that's 1. COOH. And you got to have that other right there. So methanoic acid. I can't wait to write with a pen again. This mouse is the worst. CH3, CH2, CH2, COOH. CH3, CH2, CH2, COOH. And you're going to get the hang of it. You're going to see COOH, and you're just going to know, oh, that's C double bonded O to an OH. Meth, eth, prop, but. Butanoic acid. Okay. Those are the organic acids. Now, actually, can you take a quick step back to table K, common acids? I want you to look at the last one there. The last one is CH3COOH or HC2H3O2. So this one right here, ethanoic acid, we've used it before in lab. This is vinegar, otherwise known as acetic acid. And all those other times I've said, please write it HC2H3O2, where that H is out front and then we've got the acetate polyatomic. But this is the organic form. So this is a little bit different. They're the same thing, but we can talk about how they break apart differently and all that junk when we talk about acids and bases. For right now, I just wanted you to recognize that is an organic acid. All right, then we've got something called an ester. Ester. These are a little weird. Old Granny Ester. Old Granny Ester. Okay, so why do I call it Old Granny Ester? Well, you're going to have to put your imagination caps on. It's going to be a little weird. You might not like it. So I want you to imagine. These are Old Granny Esther's eyes. She's tilting her head a little bit. So here are some eyelashes. Here's her wrinkles because she's old. Here's her button nose. There's her smile. Do you think I'm crazy yet? Well, I'm going to get rid of this. Old Granny Esther. How did old Granny Esther get so old? Well, she lived a hard life. She drank alcohol and did acid. But we'll talk about that later. For recognizing an ester, you need to see there's a carbon chain. You've got a C double bonded O to a single bonded O. There's no location needed because you've got these 2 different carbon chains, and we'll talk about how to name that. It's a little weird, I gotta say. But before we do that, have you ever seen an ester or come in contact? They have strong, fragrant odors. the chemical scents, like synthetic pineapple, wintergreen, banana, orange. Those are esters. You can make chemicals smell like wintergreen. You're like, wow, this is like mint. And it's an ester. How do you name this thing? Okay, this looks weird. Name the side chain off the single bonded O first. Like methyl, ethyl, propyl. So this is like a branch. So YL. Then name the other carbon chain and end it with O8. So methanoate, ethanoate, propanoate, etc. Okay, let's draw this. CH3. Hey, what's on the end of these? H's. Are we drawing in the H itself? No, you draw in the bond. CH2. CH2. Oh, there she is. Did you see old Granny Esther? There she is. She's smiling at you. Creepy? Maybe. All right. There's old Granny Esther's eyes smiling at you, wanting to offer you a wintergreen candy from her purse. Maybe a pineapple candy from her purse. No? Don't like it?
That's a stretch.
Don't old grannies always have like a candy? My grandma always did. She's like, here, take this candy from her purse.
Absolutely.
All right.
But I like them too, so they don't have to be old grannies.
Oh, or maybe you're old. Anyway, back to this. CH3, CH2, CH2, COO. All right, now, I've already got a bond here. I can't make 3 additional bonds as well. 3 different things. I can't do an O, and a C. So watch this. C double bonded O, single bonded O, CH3. You just get it. I know it's kind of hard to believe me, but you just kind of get it after you see it a few times. All right, so remember, single bonded O side first. Who is the chain coming off the single bonded O? Right here. What do you call that? A methyl. Everybody else. 1, 2, 3, 4. That's meth, eth, prop, but. Hey, where am I getting these prefixes from? Table P. Methyl butanoate. I don't need to give a location because I know methyl comes off the single bonded O. Butanoate comes off the double bonded O. Okay? That is an Granny Esther. Werther's Originals. Amines. These come from ammonia. So remember, ammonia is NH3. So instead of these, instead of them being H's, we're going to take one of the H's off and we're going to put on some carbon groups. So let's get rid of that. Erase pen. Ooh, take a look at this. I love how the lone pair repulses these 3 R groups away. Amines. It's found in vitamin B, hormones, dyes, anesthetics. How do you name an amine? Oh, of course, you can't read it. Parent chain plus amine. Okay. NH2CH3. So start with ammonia. Doot, doot, doot. Lone pair. 2 of these are H's. Then you've got a CH3. So I've actually seen this 2 ways. Methanamine and methylamine. I think those would both be accepted. Amine. So here's your amine. I would draw ammonia and then take off one of the H's and put the methyl group. Okay, next one. Draw ammonia. And one of them's an H. See how this says 2 CH3s? CH3, CH3. So is this an ethylamine? No, ethyl would be 2 coming off. This is methyl, dimethyl. So dimethylamine. I've also seen dimethanamine. Not one the Regents loves, but, it's still on there, so it's fair game. This is not on table R. I just wanted to, remind you of it. So not necessarily on this Regents, but you should have been familiar from the bio Regents. So an amino acid has an amine and an organic acid. So look, there's our amine, and here's our acid. This is called alanine, one of the many amino acids. If you take biochemistry or general bio, you're going to need to know those. So there's your amine, there's your carboxylic group. Amino acids are the building blocks of protein. There are 10 essential amino acids. Do you know them? How about, have you heard of them before? Maybe that. Arginine, histidine. I've heard of antihistidine? Oh, that's histamine. Oops. Threonine, valine, isoleucine, leucine, lysine, tryptophan. Oh, that's the turkey one. Methionine. You can tell I'm not a biochemist because I just really don't know all these. Phenylalanine. You ever drink diet soda? It says on the side, phenylketonurics. This product contains phenylalanine. So that's found in diet soda, and that's bad for you if you are one of those. Finally, last one on table R is called an amide. So again, we've got some ammonia derivatives, but we've got 2 amino acids, parent chain amide. Honestly, you're never going to have to do this. All you might have to do is recognize what an amide is. I have not seen it on a Regents in ages. So, all right, that is table R. That was a lot. Now it's time for some work on the worksheets. Take your time. There's a lot there. So just slow and steady practice. You'll win the race. All right. Talk to you later. Bye.